Welcome to online learning using This is Professor Tanuja Date in giving you lecture on Introduction to Numerical Integration. Let us first define why do we need integration. Integration could be indefinite integral or it could be a definite integral. If we get a constant like c and we do not evaluate it, it is an indefinite integral, whereas when we evaluate by putting some initial conditions or known data points, it becomes a definite integral. Many of the times, we need to follow this fundamental theorem of calculus while understanding the integration. If f is a continuous function in the interval a to b, capital F is antiderivative of f, that is f dash of x is equal to fx. This could be also written when we define integration as integration from a to b for the given derivative function f of x dx can be written in terms of the initial conditions put in the integral as capital F of b minus capital F of a. We are all familiar with this kind of formula which we use for calculating the integration. Now, using numerical integration, what we do is we calculate the area under the curve bounded by x-axis in given limits a to b. Suppose this is a function fx and we are trying to evaluate the integration, that means area of this function which it is binding with x-axis in the limits of a and b, which is shown by this area. Now this area can be calculated analytically by using this formula. But since computers do not understand this function as integration, we need to get some numerical method which will give us approximate calculation of this area using simpler formulas. Now, this is a set of equations or formulas which are suggested by Newton codes, which are known as Newton codes methods for calculating integration. What we do is we try to fix a function to the given data points in the form of either a polynomial of order n or it could be a linear function. When we fix a particular polynomial, we can get the function evaluated f of x as either a0 plus a1x plus of an x raised to n dx form, where we are a polynomial of order n to the function which is a suggested polynomial suitable for the data points. So it is an approximation. If we suggest this polynomial, we can easily integrate this as a0 b minus a1 into b square minus a square upon 2 by putting the upper and lower limits, and we can evaluate this. Using this, the Newton codes method is giving us various formulas where it uses a trapezoid method, assuming only two data points which are known, where the function is approximated using only two terms of order a0 plus a1x. So this is using only two data points where a0 and a1 points can be evaluated to make it a specific solution. It is called as trapezoidal method. If it is a Simpson's 1/3 rule, it uses a second order polynomial and it can be fixed as a0 plus a1x plus a2x square and so on. First, let us study about trapezoidal method. In trapezoidal method, what is done is this could be any function whose nature is not known, but we assume that we have two data points which are available as a and b as the limits of on x-axis, whereas f of a and f of b are two data points which are available, which are describing the function and they are lying on the function. Using these two data points, we can find out the integration. When we convert this by fixing f of a plus f of b minus f of a upon b minus a into x minus a as the function which is using a linear or 2-point polynomial. Using this 2-point polynomial and evaluation of a0 and a1 points gives us a formula which is nothing but calculation of area of this trapezoid, which is formed by f of a and f of b. When we join together, b minus a becomes the vertical distance between these two. So b minus a into f of b plus f of a upon 2 is nothing but the formula which can be used for calculating area of this trapezoid. Now this formula is approximate, but it gives us integration using only 2 points, which is a popular trapezoid method. Now let us calculate. Under what condition we need to use this integration formula in numerical methods? In numerical methods, suppose we want to estimate velocity of the object when time and velocity are given, and we want to estimate the distance travelled in a particular interval. Now we understand that distance is an integral of velocity, and so it can be written as integration of velocity with reference to time can be calculated in the range of 0 to 3, which is given the interval. And this distance can be calculated by analytical formula like this. But since we can't use this analytical formula, we need to use these data points which are available and which can be used using trapezoidal method. Now let us try calculating these using trapezoidal method. Assuming that this is the starting point and this is the ending point, we can use the trapezoidal formula by taking the first value f of a plus f of b, okay, and we can calculate. Now here this method is used by considering the number of all the data points which are given. But suppose we are knowing only the starting point and the ending point, we can try calculating this using the formula which we have seen as b minus a into f of b plus f of a upon 2, which can evaluate this as 0 plus 14 divided by 2 becomes 7, and b minus a is 3, so 7 by 3 could be the answer. I'm sorry, it should be 7 into 3 because 3 is b minus a and 14 plus 0 divided by 2 makes it 7. 7 into 3 will become 21. Okay, that is the answer. Now when we see, if we use all the data points including in between data points, the result appears to be 29, which is different than what we have seen just now. Now why this change has occurred, we can again check. Because we are using multiple data points, instead of using only starting and ending data point, we are subdividing this interval into sub data points, assuming as if there are 3 sections for which 3 trapezoidal areas are calculated and are added together to get the final formula. Now this area is calculated for each trapezoid by using the trapezoidal rule. But when we take sum of all these areas together, we can see that the error which is seen in case of trapezoidal rule can be reduced. Now there are 2, if the interval could be even, which could be equal interval, for which we can assume x, the next data point minus previous data point, as the interval to be h, and then we can derive and get this formula as h to be the distance between 2 consecutive data points into half of the starting point function value, ending point function value, and sum of all the function points which are in between for the sections. So this formula will be used for equally spaced data points. If it is not equally spaced, every time we have to take the displacement between two consecutive data points and multiply it with the sum of those two consecutive data points. Mainly we will be using this formula, which is popularly known as multiple section trapezoidal method. Now these slides are showing us the error which is associated with trapezoid method. We can see that the error could be of order b minus a upon 12 x square, maximum of f double dash of x, where x lies in the range of a to b, the range which is given. We can remember that this error needs to be reduced and minimized when we are using multiple data points. This is one example which you can visit later for calculation of the number of sections which can be considered for limiting the error in the given accuracy level, and we can try checking how it is calculated. Okay, this is another example where multiple data points are given, and we will be using this multiple data point formula for calculation of the integration which we have calculated in the range of 1 to 3. You can see that the summation is taken for not the starting point and ending point, but it is taken for all intermediate data points, where it is starting point 3.2. Okay, F1 is 3.2, 3.4, 2.8 are the intermediate data points which are added, and starting point 2.1 and 2.7 are added and divided by 2. So the result is gained, which is 5.9. Now when we compare this calculation by using normal trapezoidal method, where we will be considering only the first data point and the last data point, we can see that this calculation would be different, where h value would turn to be 3 minus 1 to be 2, and we will be adding only 2.1 and 2.7 to be divided by 2. So it will become 4.8 upon 2, which is 2.4 multiplied by 2, and so the value will be different than this. So error associated in multiple data point consideration would surely be reduced. Now, I expect that if you have understood these two variations of trapezoidal method, you can try solving same problem by taking only the first and final value of the range which is suggested for integration for trapezoidal method, and then take multiple data points in between by taking 3, 4, 5 sections, and you can compare the error which is associated to check the accuracy of both methods, where you will conclude and realize that multiple section data point trapezoidal method gives better results because the accuracy is improved. I expect that you have understood these two methods and you will try solving all the problems which are given in this presentation. Happy learning!